Okay, we'll look at how to evaluate trig functions without a calculator, and that's all based on knowing your unit circle, which you quizzed on, I guess, today. So don't forget what the tangent and the cotangent and the secant and the cosecant are in terms of sine and cosine. You must have those memorized, because even though I don't think cotangent, secant, and cosecant are used in any of these first 15 problems, you know, they could pop up on the next thing. I do see some tangents here. All right, let's start with the sine of 45 degrees. This is one that you should have memorized. 45 degrees is the square root of 2 over 2. Okay, and again, as I'm doing these, you already have done them in advance and you're just checking your work and then looking for help if you get stuck on something. What's the sine of 5 pi over 3? Now 5 pi over 3 is also 300 degrees, so it's in the fourth quadrant. And we know that it's negative. Sine is negative in the fourth quadrant because sine is the y value. And so what is it negative of? Well, it's negative square root of 3 over 2. Okay, I'm not looking at the unit circle. I'm not looking at a table. I'm doing this for memory. I can picture the unit circle in my head. The tangent of 45 degrees. Now, if you don't know your tangents, don't panic. As long as you know your sines and cosines, you're good. This is the sine of 45 degrees over the cosine of 45 degrees. So this is the square root of 2 over 2 all over the square root of 2 over 2, which is 1. What's really nice about 45, 135, 225, and 315, the ones that are on the diagonals on the unit circle, is that the tangent and the cotangent are either going to be 1 or negative 1 depending on the quadrant. First and third quadrant, 1. Second and fourth quadrant, negative 1. Okay, speaking of a third quadrant angle, that's right on that diagonal. 180 plus 45 is 225, but this time it's the cosine. We know cosine and sine are negative in the third quadrant, so this is negative square root of 2 over 2. Here's one that's on this diagonal, 135, it's 90 bigger. It's a 90 rotation. Anyway, the sine of 135, sine is the y in the second quadrant is positive. This is positive square root of 2 over 2. The tangent of 180, well, the tangent of 180 is the sine of 180 over the cosine of 180. Now, the sine of 180 is 0. The cosine of 180 is negative 1, so it's equal to 0. Now, if you get 0 in the denominator, which you would at 90 or 270, then we say it's undefined, because you can't divide by 0. The sine of 180, I just had to figure that out here. That's 0. The tangent of 7 pi over 6, which is the same as 210 degrees, is equal to the sine of 7 pi over 6 over the cosine of 7 pi over 6. I hope I left myself enough space here. This is negative 1/2 over negative square root of 3 over 2, which is negative 1/2 times the reciprocal, which is negative 2 over the square root of 3. The 2's cancel, the negatives cancel. I end up with 1 over the square root of 3. You've got to rationalize your denominator by multiplying top and bottom by the square root of 3. This turns out to be the square root of 3 over 3. Alright, the sine of 5 pi over 6, that's in the second quadrant, that's positive. That's the same as 150. This turns out to be positive 1/2. Again, from the unit circle. Not a lot of work to be shown unless you're doing a tangent. The cosine of 240 is in the third quadrant. It's going to be negative something. Well, in 240, it's going to be negative 1/2. I have to picture that. The sine of 240 is negative square root of 3 over 2. The cosine of 150, now I just did the sine of 150, I thought. Yep, the sine of 150, 5 pi over 6 is right there. The cosine is going to be negative in the second quadrant. And what goes with 1/2? Well, when the y is 1/2, the x is square root of 3 over 2 or negative square root of 3 over 2. That's one of the patterns. What's the cosine of pi? Well, the cosine of pi is the same as the cosine of 180, which is negative 1. What's the sine of 330? Sine of 330, that's all the way into the fourth quadrant. That's the same as 11 pi over 6. Well, the sine in the fourth quadrant is negative because it's the y value, but negative how much? Negative 1/2. The cosine of 315, all right, the cosine of 315 in the fourth quadrant, between 270 and 360, is positive. But how much? Well, that's one of those diagonal ones. That's going to be the square root of 2 over 2. When I say a diagonal one, I mean on the unit circle here, it's the one that has like slope negative 1, slope positive 1, like bisects the quadrants. All right, so the tangent of 300 degrees is the sine of 300 degrees over the cosine of 300 degrees. Well, the sine of 300 degrees, that's in the fourth quadrant. Sine is negative. That's negative square root of 3 over 2. The cosine of 300 degrees is a half, so this is negative square root of 3 over 2 times the reciprocal, which is 2 over 1, and the 2's cancel. I get negative square root of 3 over 1, which is negative square root of 3. Forgetting to circle some of these. 3 more. I think this is still the first page here. Now notice here they tried to sneak one past the goalie. They gave you a negative. And not only did they give you a negative, but this one is a pretty small negative because it's smaller than negative 2 pi. I'm going to take negative, I'm going to put some work right up here. I'm going to kind of scratch work up here. I'm going to add 2 pi to negative 13 pi over 4. I know that doesn't look like much, but that's negative 13 pi over 4. If I add 2 pi or 2 pi over 1, that's the same as multiply top and bottom by 4, 8 pi over 4. So that gives me negative 5 pi over 4. Still too small, it's negative. I add another 2 pi. So negative 5 pi over 4 plus 2 pi, which is 8 pi over 4, gives me 3 pi over 4. So this is the same as the sine of 3 pi over 4. Now the sine of 3 pi over 4, it feels like I've done that one. I sure did. 135 degrees and 3 pi over 4 radians are the same angle. This is square root 2 over 2. I'm never going to get that looking at it in this form. I must find a coterminal angle to make this a lot easier. A coterminal angle between 0 and 360 or between 0 and 2 pi. Here's another negative, but this one's not that small. So if I add 2 pi to that, here I'll just do it up here, negative pi over 4, if I add 2 pi, which is the same as 8 pi over 4, I get 7 pi over 4. So this is the same as the cosine of 7 pi over 4. Well, the cosine of 7 pi over 4, have I done that one? I feel like I've done that one too. Maybe not. I sure did right there. The cosine of 315 degrees is the same as 7 pi over 4. So this is the square root of 2 over 2 as well. Now this one is positive, but it's too big. I'm going to have to subtract 2 pi. Looks like I'm going to have to subtract it twice. Let's see, I'm going to just do some scratch work up here. 14 pi over 3 minus 2 pi over 1. Common denominator is 3, so I multiply top and bottom by 3. I get 6 over 3, so that's going to give me 8 pi over 3. Still too big. That's bigger than 2 pi. 8 over 3 is bigger than 2, so that's bigger than 2 pi. So let's subtract another 2 pi, which is again 6 pi over 3, and I get 2 pi over 3. So I'm telling you that this is the same as the tangent of 2 pi over 3. Now I doubt if I did the tangent of 2 pi over 3, that's going to be pretty lucky. Nope, I haven't done that one yet. So let's go ahead and find this. This is the sine of 2 pi over 3 over the cosine of 2 pi over 3. Now the sine of 2 pi over 3, that's going to be positive square root of 3 over 2. Cosine of 2 pi over 3 is going to be negative 1/2. So this is positive square root of 3 over 2 times the reciprocal, which is negative 2 over 1. So this is going to be negative, because I have a positive times a negative. The 2's cancel. Square root of 3 over 1 is just the square root of 3. It's negative square root of 3. And that is how fast I did those first 18 problems, just like that. Now the other problems were a bunch. I think you got like 40 problems or something. So I didn't want 30 more problems. So it was at 48 altogether. I'm not going to do them all, but I'm going to do enough of them so you can do the rest. Notice it says find exact values. They don't want you grabbing a calculator and looking this stuff up. They want you figuring this stuff out. Now, I don't like the way that he has set this up. I looked at his notes and I looked at the way he's got his answers listed for these problems. He's listing 2 answers here, but there's only one in all reality. But he's listing 2 because he's listing all 4 quadrants, and so typically if it's positive in one quadrant, it's positive in another. Negative in one quadrant, negative in another. He's listing both. So what we're going to do here is we're going to find the angle whose cosine is the square root of 3 over 2. That's what this means. This is equal to some angle such that the cosine of this angle is equal to the square root of 3 over 2. Now we've been punching that into the calculator enough. We should have an idea of what it does. It finds the angle. And it doesn't indicate degrees or radians, so I'm just going to put them in degrees. Now cosine is positive in 2 quadrants, first and fourth. So if you were to push the inverse cosine of this square root of 3 over 2, you would get a first quadrant angle because that's positive. This is positive here. And cosine, the range is between 0 and 180. It's not going to give you something between 90 and 180 because that's when cosine's negative. It gives you the full gambit in those two quadrants, first and second. So what I have to do is I have to find my angle and use it as a reference angle. So in this case, my angle is, let's see, 30 degrees. The cosine of 30 degrees is the square root of 3 over 2. But remember, cosine is also positive in the fourth. So he does in the fourth, he does 360 minus 30 and gets 330 degrees. Now let me check his answers to see. Now he's doing radians. No, he does both, so it doesn't matter, I guess. But this would be the same as pi over 6, and this would be 11 pi over 6. Very similarly, the inverse sine of this number is also an angle, such that the sine of this angle is equal to the square root of 2 over 2. Now we know sine is positive in two quadrants as well, first and second. But when you do the inverse sine, the range for this function, this weird function, is between negative 90 and 90 inclusive. It's like in the first and the fourth. Not the fourth quadrant like 300, but the fourth quadrant like negative 60. The range of this guy is between negative 90 and 90 degrees. So if this is a negative number, I'm going to get a fourth quadrant angle that's going to be a negative angle. But this is positive, so there we go. We're living life large here. So I do the inverse sine, I do the sine of what angle is the square root of 2 over 2. Well, that happens at 45 degrees, or it happens at 135. Because 45 is now my reference angle. In the second quadrant, it'd be 180 minus my reference. 180 minus 45 puts me at 35. Remember, sine is positive in the first and second quadrants. All students, sine is positive. So not only do I have 45 this way, but I also have 45 this way, so that's 135. That's where that angle comes into play. I use the 45 as the reference angle in the second quadrant. That might be the trickiest thing that you have to see. Or maybe these ones down here, I don't know. This guy over here, this is another angle. Now notice they use arc sine. That's a little bit more old school. It's the same as inverse sine. Arc sine means that this is equal to some angle such that the sine of this angle is equal to negative 1. Well, the sine of 270 degrees is negative 1, but if you punch that into a calculator, it's not going to say 270 degrees, it's going to say negative 90 degrees, because again, the range for, for arc sine, the range is between negative 90 degrees and 90 degrees. For arc cosine, okay, or inverse sine, inverse cosine, the range is between 0 and 180. So when you punch them into your calculator, you're going to get angles in these intervals here. So this is going to be negative 90 degrees if I punch this in, but I don't think he wants a negative 90. Let's see if he does or he doesn't. He does not, because he wants it, I believe, between 0 and 360. So even though this is going to give me negative 90 degrees here, by definition, I'm going to use that and say, okay, negative 90, that is the same as 270. So 270 degrees is the answer. You say, well, shouldn't there be a second answer? No, because arc sine is only equal to negative 1 at one angle. It's a quadrantal angle. Okay, you can get 0 at two different angles. You can get 1 at one angle and 1 at the other. The sine of 90 is 1, the sine of 270 is negative 1. So you're only going to get one answer. Most of these have two answers. You're only going to get one there. Alright, this guy over here, oh no, not an arc tan or an inverse tan. Because the inverse tan, if I have a space here, or arc tan, its range is between negative 90, not inclusive, and 90, not inclusive, because it's undefined at the endpoints. So I got to find an angle between negative 90 and 90, and notice it's negative. Yikes! So it's going to be a negative. It's going to be a fourth quadrant angle. Not fourth quadrant like 300 degrees, fourth quadrant like negative 60 kind of a degree. So I have to think, okay, what tangent value there in the fourth quadrant? Well, in all reality, this is equal to negative 30 degrees. That's what you're going to get if you punch it in on your calculator. That's how it's defined. We know that the tangent of negative 30 degrees is equal to negative square root 3 over 2. Let's see if I got that right. I got that right. So, since I've got to find the actual two angles here that are positive, this 30 degrees is going to be my reference angle. Tangent is negative in the second and in the fourth. So 180 minus 360 minus. You can see that these are coterminal right here. If you add 360, you get to that. And I believe that those are the two answers that he has, although I don't think he had all the answers. No, he doesn't have the answers to the evens, just to the odds. So here we go right here, here we go right here, here we go right here, and just the one guy right here. All right. Now, if I do this on my calculator, this is going to give me a second quadrant angle, because remember, our cosine, the range is between 0 and 180. So since it's negative, it's going to be in the second quadrant. So I kind of have to say to myself, what second quadrant angle has a cosine that's negative square root 2 over 2? Well, that's 135. 135 degrees. So alpha is 135, but cosine is also negative in the third quadrant. What's your reference angle on a 135? 135, your reference angle is 45 degrees. So this in the third quadrant, it's going to be 45 this way. 180 plus 45, 225 degrees. Now it's getting intense. Inverse cosine of 0. Well, it's got to equal some angle such that the cosine of this angle is 0. Where does that happen? That happens at 90 and at 270. Now if you push this in on your calculator, or this in on the calculator, it's going to give you 90 degrees. But it's also, cosine is 0 at the other quadrantal angle at 270 degrees. So my angles would be 90 degrees, 270 degrees. Or pi over 2 radians, 3 pi over 2 radians. Now it gets a little bit different here. They're asking you to take the cosine of an inverse sine, or the sine of an inverse cosine. Remember, this is an angle. So you're just taking the cosine of an angle. This is an angle. So you're taking the sine of an angle. This is an angle. So you're taking the tangent of the angle. So what angle do we get here? Well, let's see what we got. The cosine of negative sine, inverse sine of square root 3 over 2. The inverse sine of square root 3 over 2 is in the first quadrant. This is the cosine of, this is the cosine of the angle whose sine is square root 3 over 2. Well, that happens at 60 degrees. And the cosine of 60 degrees is a half. Now, you're not going to like this, but there's another way you can do this, and you can do this with a right triangle. The reason I can do this is because this is a first quadrant angle. I'm going to put it right there. I'm going to call it alpha. And what do I know about this first quadrant angle right here? I know that the sine of this angle is the square root of 3 over 2. So the sine, which is the opposite over the hypotenuse, Pythagorean theorem, this turns out to be 1/2. Let's see. Yeah, this turns out to be 1/2. It's just not drawn to scale. And you can see that I have a special right triangle here. So what, let's see, it's 1/2, or is that 1? That's 1. Good Lord, that's 1. Pythagorean theorem here. It is still a 30, 60, 90. This just happens to be the short leg, which is half the hypotenuse. So this is 30 degrees. This is 60 degrees. So I'm finding the cosine of this angle here, 60 degrees. Well, the cosine is the adjacent over the hypotenuse. 1 over 2, 1/2. Now, I'm not thinking you're going to like the right triangle business, but that's exactly how I'm going to do these three bottom ones right here. These other ones I can do if I know my unit circle. What is the inverse cosine of negative 1/2? Second quadrant. Negative 1/2 would be 120 degrees. So this is saying, what's the sine of 120 degrees? Well, that's the square root of 3 over 2. What's the inverse sine of 0? Because I'm going to take the tangent of it. Well, the inverse sine of 0 is 0. So I'm taking the tangent of 0, and that's 0. That was easy. Now these last three, notice they don't give you a nice value like square root 3 over 2, or square root 2 over 2, or 1/2, or 1, or 0, or their opposites. They give you something else. So this is where we go with the right triangle. Now notice, positive, positive, positive. So all of these angles right here, because that's an angle, that's an angle, that's an angle. You can get your calculator out and approximate it if you wanted to. All these angles are acute angles. So I can draw a right triangle even though my right triangle probably won't look right. And I'm going to call this angle alpha, and what do I know about this angle? I know that the sine of alpha is 8/17. So if this is alpha, opposite over hypotenuse. Use the Pythagorean theorem, this is 15. What am I trying to do? I'm trying to find the cosine of alpha. The cosine of alpha is 15/17, adjacent over hypotenuse. And there's my answer. Let's see. Oh, I underlined those. Oh, I didn't underline this one. Oh, and I circled this one. And I'll circle this one. Here we go. Alright, let's try it again. Okay, this is an angle. I'm going to call it alpha. I'm just going to cover up the sine part for right now. What do I know about this angle? I know that the cosine of this angle is 5/13. So if I draw a right triangle, call this alpha here, not a very good right triangle. What do I know about it? I know that the cosine is 5/13, adjacent over hypotenuse. Use the Pythagorean theorem, this is 12. What am I trying to do? I'm trying to find the sine of this angle. 12/13. One more. Fortunately, these were all nice Pythagorean triples. No square roots. Alright, same thing again. This is an angle. I'm trying to find the tangent of this angle. What do I know about this angle? I know that the cosine of this angle is 3/5 by definition. So if I draw a right triangle and I call this alpha, 3/5 is adjacent over hypotenuse. Pythagorean theorem tells me that this leg is 4. What am I trying to do? I'm trying to find the tangent of this angle. Opposite over adjacent. This is 4/3. And there's my answer. Now, he gave you the answers to a bunch of the odd number problems, but didn't give you all the evens. However, I gave you some evens. 1, 2, 3, 4, 5, 6, 7. 7 out of the 10, I think, or 7 out of the 15. So you got a big jump on this. And I'll be happy to help you with the questions. And if you need for me, I can sit down with you and we can go over this stuff. But try the problems first. Look at your notes. Try the problems. Think about it. Try them today. Think about them. Give me a call if you have questions.